how much work is done by this force as the object moves from -1 meter to +2 meters. What can we do? Take the integral. Any question on that?
No.
Good. So we keep moving. So when we have an inclined plane, how to apply the concept of work? Inclined. Same thing. It's pretty much the same thing. Except that you have to be careful with the work done by the gravity, which is the more complicated. But I will explain in the easier manner to get the work done by the gravity. Let's say that we have an inclined plane, like a hill, and we are pulling a block with the force F, which is parallel to the incline. Parallel to the incline. Let's say that that force is, for instance, let's say that the object is moved at constant velocity, for instance. So, V is constant. If the mass of the block is 10 kilograms, not always the mass of the block is 10 kilograms. Let me specify. I am putting 10 kilograms just to make, not always the problems in physics will be block. So sometimes can be a truck. I am just in the simplest way giving one model. From that model, you just look at the different things that they will give. Okay, the angle of the incline given 30 degrees. Mu given 0.2. Not always the coefficient of friction is 0.2. The question is A, find the work done by each force. What will be B? Find the network. You know that those questions are typical. Okay, let's start finding the work. In order to find the work, let's start what are forces are acting here. On the block, what forces? Normal force. What else? Gravity. What else? Friction. Can you see that those are the forces? Good. I need to find the work done by each force. So, with what force we start? F, which is usually the one that is moving the object. F, time delta x, time cosine of what angle? Right then. What did I say that is the definition? Alpha. What is alpha in that case? You look, if you cannot do it because you don't have intuition or spatial cognition, you use your hand. In which direction is the displacement? In which direction is the force? What is the angle between them? What is alpha? 0. So no problem. In the test you can do it. You know, you can do like this and I won't have any problem.
So it's like the direction of the acceleration.
Is the direction of, in this case, it's accelerating in the direction of the displacement. So it's displacement and force. What is the angle between them? 0 degree. That's the angle you have to include as alpha. It's not theta. So cosine of 0 degree. Do we have the force? Do we have the force? No. What can we do? Find it. If we don't have the force, you find it. How do we find the force? How do we find a force? Newton laws. Newton laws. Sigma F along x or along y is the force. F. So what will be sigma F in this case? Tell me. Along x. F minus what? Minus friction. Minus what? FGX. What is FGX? Mg sine theta. Equal to what? 0. Why 0? Because it's moving at constant speed. If I am not telling that it is moving at constant speed and I don't give the force, I have to give the acceleration. Or I have to give B initial and B final and the time to find the acceleration. Or I mean, sorry. I have to give any certain information where you can find the acceleration. And you put ma here and you find the force. But because I set a constant speed equal to 0, can we find the force? So will be mg sine theta minus the friction. What is the friction equal to? Mu times what? Normal force. What is the normal force on the inclined plane in this particular case? If Fgx is mg sine theta, what will be Fgy? Minus mu mg cosine theta. This will be the force. Any question? Now I have the force, now I can find the work. Mg sine theta minus mu mg cosine theta. What plus?
The force. The force minus friction minus perception.
Oh, plus, yes. Good. I have that force. Any question? So the force is overcoming the gravity and is overcoming the friction. That is the meaning of that. Okay, I got F. Now can I find the work? Since I have F, I have delta X, and I have theta, alpha, I can find the work. So what is new so far in this chapter? Two formulas. This and this. The rest is based on what we learned already. So if you didn't learn it, now I will catch you again. So if you didn't learn what was in the test, better learn it, because in the second test you will have things where you have to apply. Not necessarily will be exactly the type of question, but where you will apply. So do the homework, go again to the Newton laws to understand, because it's needed for this part. What is the inclined plane? What is Fgx? What is Fgy? Okay, we have F. Now you substitute here and you get the work done by F, which is mg sine theta plus mu mg cosine theta